So today I'll show you how to design very easy and quick any compressed air systems. We see here the open piping that is drilled, and you can easily drag and drop here the photos, put some parameters, and simulate this open piping within the standard components that are presented in our EasyCAS. Drag and drop the element such as a compressor, and the holes of the piping will be presented by the open tube, the piping, and the T-connector. Put them together and connect green with red. You can copy and paste. In this sense, now you are simulating open holes inside one big pipe. Before you start this, just count a number of them, the distance between the holes in the pipe, and as you see here in the video, connect them all together. On the lower panel, you can rotate the elements, copy paste them, as well as delete them. With every single tube that is presented here, simply parameterize it as a length between the holes of the pipe. Here now you can see that we have about 20 of holes, and in this way you can now calculate how much this kind of tubing will consume. By double-clicking, you can align the component with the previous one. Here in this application, I have 2 rails of open piping, and this is a huge consumer. So just simply copy and paste, put the T connector in order to connect both of piping, red with green. And now you can calculate the consumption of entire 2 rails simply by clicking on calculate, adjusting your input data, and now by clicking on the compressor element, you can see the required pressure levels, flow rates, as well as the cost of compressed air and new compressed air cost, and so on. Adjust very comfortably the design. Put now a new application. In this case, you see there are cylinders. Put the photo as well as the results of your audits here. And for the cylinder, the program will ask you to put the parameters that are required for it, such as time, pressure levels on the pressure gauge before the application, length of piping between the valve and the cylinder drive. Choose the valve. For the consumption calculation, it's not so important to create an exact valve that is installed there. It is simply for the demonstration, but you also, of course, can put the check valves with throttles to calculate the velocities and other parameters. But in this way, it's just enough to have a valve. Copy and paste your application. Because I have about 6 or 8 cylinders in this application, just simply copy and paste them. Now you can put a second compressor here. A compressor in this way represents just a source of the flow and the pressure, or you can connect with the previous tube. But in this case, I want to show how different those applications and how much they consume separately. Use the connection pipe, elbows, teeth, and other connectors that you can find in the database on the left, on the right hand in the library of the elements, and simply use it to connect. Use again the copy and paste to connect the elements. It can take you about few minutes to represent an exact application of the machine. You can also recalculate the cylinders simply by clicking on the recalculate your alternative cylinder. But here let's just focus on the building the pneumatic system. Double click on the element so it will align with the previous element. If you want to delete connection, choose the element and press the right click. After the design is completed, the program will ask you to put the parameters, and as you can see now, you see the information about on the element that is named compressor, where you see the pressure, flow, and other important parameters about the consumption of these elements. Now you can compare it, use the connection of the two in order to represent the whole system as it is here. Put the T connector or put the regulator, just double click, and now you can simulate the system more realistically. I recommend in this case always to start simply, so meaning one compressor, one application, one compressor element, one application. After the application is correctly completed and the data is correctly completed, simply delete the element that is not required and connect them as I show here in the video. Now you can see it took about 15 minutes to complete the two application for audit of one production line. In the element named regulator, you can choose the pressure that goes into the application and as well as the pressure that is before the regulator. Usually it is a supply pressure. The application will always, the EasyCAS will always tell you what is the required setting on the regulator in order to have the optimized system. Now check again your input parameters and we can continue with other applications. In this particular machine, I have one rail for the cleaning and as well as few stations with cylinders and with nozzles. In this case, I built exactly similar application, but it will be 3 cylinders. And here I want to have a more precise calculation of the velocity control. In this case, for the velocity control, we always put the throttle with the check valve. And this is called here the meter out velocity control for the cylinder drive. This is a critical step for me, but in case you just want to analyze the energy consumption of the application, simply remove the throttle and check valve. However, of course, it will impact the regulation of this. It will impact also the flow. Now you can see the sign that some elements are not connected. For example, in the valve, in the cylinder that is bottom down. And I simply copy this, add connectors. T connector allows me to connect with the elements. You, of course, can do more detailed simulation and put the elbows and other fast coupling, everything what you find in the database. Here I just want to calculate the entire consumption, compare it with my measurement data, and that would be already enough. If you want to analyze all the pressure drops and find the most restrictive component along the line, please do it in every single detail as it required for your design. Again, I checked with the compressor, everything was working. Now I use one element compressor with the pressure regulators for all stations of my machine. You see now the restrictive components and the alarm elements. It shows you the pressure drops. It shows you the ideas for the optimization that we'll show in the next video. But here you can see that the restrictions in the pipe diameters causing higher pressure drop that we choose in the optimization. Now I upload everything into my project management base. You can change all the elements and you can see entire bill of material of your system.